This is a new example then of some trigonometry. It's expressions of the form a cos theta plus b sine theta. So for instance, you might get something written like 2 cos x plus 3 sine x. And we essentially want a way of rewriting that in a nicer way. Basically, because it says coses and sines, we can't do much with it. So we want a way of combine them into a better version. So this is what we're going to look at. We're going to use a package called Desmos. So I'll just, whilst I'm doing this, I'll just see if I can switch to Desmos. So I'll just go over to Desmos, and hopefully you then be able to see all of this stuff. Well, you can see most of it. I'm just going to slide this over. It might help me if I do that. So now I've done that, I'm going to type into slightly off screen, I'm going to type what it said on the PowerPoint. So if I just go back to the PowerPoint, it wants me to draw 4 cos x plus 3 sin x. So if I just go back to that, so I'm going to type in y equals 4 cos x, it's already done that, plus 3 sin x. I'll just check that that's what it wanted. 4 cos plus 3 sin, yes, and the window's already set up, and that's what it looks like. And then on the PowerPoint it says, draw the graph of y equals cos x. So if I draw this graph as well, I can draw a second graph, y equals cos x. Yeah, it's slightly off screen, but that's y equals cos x. And you'll notice it hits at 90, then it hits at, gets down to the bottom 1. This is the graph we know. And I suppose the question is, what do I do to the blue graph to make it into this red graph? Because they are similar. They both go up, they both go down. I suppose there's a slight difference in as much that one's taller than the other. That goes up to what looks like, it goes up to exactly 5 actually. So that's 5 it goes up to, whereas this goes up to 1. So that might suggest a transformation. But also it seems to have been sort of translated to the right a bit, and that doesn't look quite such a nice angle. And yet here we have on the second slide, I've suggested that if we type in this, y equals 5 cos of x minus 36.9, it's the same. So let's just go back to that. Let's see if I agree. So I'm going to type in the third one, y equals 5 cos in brackets of of x minus 36.9. Now it's minus because you have to shove it to the right. Oh, that's interesting. Straight away it's gone right on top of the other one. Notice if I change it just, I don't know, to some 40 number or something like this, you'll notice it's slightly out. But if it's exactly 36.9, it seems to have gone bang on top of it. So that is the right answer. So the question is, and we're back now to where we more normally would be. And the question is then, if this is what we are looking at, this is you could describe the blue to the red as a stretch of scale factor 5 in the y-axis, parallel to the y-axis, and then a translation of 36.9 to the right, which is what this vector shows. And again, notice I'm here, I'm just going to say, oops, I'll go back, it's y equals 5 cos x minus 36.9. It's just gone slightly off the bottom. But other than that, it's right. So bear that in mind, because what it says is we can write these expressions in this alternative way. So if I got 4 cos plus 3 sine, I can write this as r cos x minus alpha. Now, forgive the notation, it's always r, it's always alpha. Interestingly, it doesn't have to be cos, it could be a sine, but usually in an exam question they'll tell you what they want you to use. So I suppose this is my logic on this. I know an expression for cos. Cos says, if you remember cos of a, well, I've got a minus, so I'm going to write minus, and it becomes cos a cos b, and you always have to change the sign for cos, you should remember that, plus sine a sine b. Now I've got an r in front of mine, so I suppose mine becomes r cos x cos alpha plus r sine x sine alpha. And now what I do is I look over here and I say, oh, this is 4 cos x, this is, well, kind of, if I join those together, I can kind of say that r cos alpha must be equal to that 4. Because that says 4 cos x, and here the number of cos x that I've got is r cos alpha. And I've also got a statement saying a sine x is over here, and I've got sine x over here. So this is called equating coefficients. And it tells me that r sine alpha must be equal to that 3. So you get these two equations, and now our job, I suppose, is to find r. Now, look, the easiest way to find r is just to do a little trick. R squared is 4 squared plus 3 squared. That actually comes from the rule for cos squared plus sine squared. I could square both of these, but you just use a bit of Pythagoras effectively, and that gives you, if I do it, 25, and therefore square rooting gives me r equals 5. Now, so straight away then I now know that cos alpha equals, that's 5, so move that over gives me 4/5. Or said differently, sine alpha is 3/5 using the second equation. And this allows me to find my alpha just from here. So if I just do that, I'm hoping it's 36.9. Make sure you're in degrees, because otherwise you're going to get it wrong. I am in degrees. So inverse cos of 4 divided by 5 is 36.87, so 36.9. Just do the other one. Just make sure to yourself that you get the same answer. You should get exactly the same answer. Now that is not always the case. In this case you should. Just check it. So we finish with a statement that 4 cos x plus 3 sin x is actually equal to the 5 cos x minus 36.9, which is of course what we had on our graph on the previous slide. This is the method that we're going to try to use. This is slightly different straight away. I notice that the question is in radians, so that's going to give me a little bit of work to do perhaps. It says sine cos, it wants it in this format, so I'm just going to use my formula for that one. So let's start off 2 sin x minus 5 cos x. So write alpha to 2 decimal places, okay, fair enough. And it wants me to write it, so I'll write it as equivalent to r sine x minus alpha. And the trick is to write your formula for sine of x minus alpha, and you should remember it becomes sine of the first one, cos of the second one. And because it says minus, it will be a minus r cos of the first one, sine of the second one. And because I've got sine x's here, where's my sine x's? Here's my sine x's. I can write r cos alpha, do the same trick as last time, is equal to 2. And where's my cos x? There's my cos x. R sine alpha. Now notice it says minus, and it says minus. It's because you've got the agreement here that these two equations work. Minus, minus. So that's going to be 5. So I use both of them. Some people don't. They kind of use one of them, or a combination of them. I like to use both just to check that my answers give me the same answer, but with both of them. And if I do, then I know I've not made any daft errors. First of all, remember r we can find by a bit of Pythagoras. Now, r squared equals 2 squared plus 5 squared. It's always plus, just whack them in, and again you can prove it using these formulas here effectively by squaring all sides and adding the equations together, but this is much easier. R squared then must be 29, so I reckon r is root 29. Now I've got that, my cos alpha according to me is 2 over root 29, or said a different way, sine alpha is 5 over root 29. So if I do this, I'm going to do, now I'm in radians now, so make sure you're in radians. Second function, angle unit is in radians. So it's 2 divided by root 29, and I've got that, and I inverse cos the answer, and I get 1.19. It says gave it to 2dp, and yes, that's right. Just do it the other way around as well. Hopefully you'll get the same answer. Good, I did. And notice what I've ended up doing. Again, technically that should have 3 lines, but it doesn't really matter. 2 sin x minus 5 cos x can now be written as root 29 sine, and it's sine because this is what it says, x minus the alpha, which is 1.19, and that's my answer. So in summary then, we have these set processes that we go through. We first of all check, and this is something I haven't shown you yet, we check that the ordinary signs of the expansions are correct. I'll show you that in a bit. We expand the addition formulae that we've done. We find we equate coefficients, we find alphas using cos and sine. And if the answers are the same, we're sorted. If the answers aren't the same, we've got a bit of a problem. So let me show you an example then, where the answers aren't the same. Put my pen back. It says, so this is an example. It says 2 sine x plus 3 cos x. So if I do 2 sine x plus 3 cos x, it says as r sine x minus alpha. So just be aware then that what I'm trying to do here is I'm trying to write it as r sine x minus alpha, and of course that is r sine x cos alpha plus r cos x sine alpha. So actually it's nearly there, just got to be a bit careful is what I would say. You've got to be careful because it says 2 sine x, and well, it says 2 is therefore equal to r cos alpha. So that's actually all right, isn't it? We've got 2, and we've got here. Now that's my problem here. It says minus. If it's a minus, it's a minus. And so here I've just got to be a bit careful. This one's fine, but it's this one because it says minus r sine alpha is 3. And so it'd be quite easy to get this wrong because of that change of sign. I suppose that's better written over here as a minus 3. So just be aware that you could end up with the wrong sign. And personally, I don't like it when it's like that. The second one, I've got an answer for you there, but I'm going to come back to that perhaps in a bit. This one has also got a problem on it, as much as it says sine x plus 5 cos x. So again, I'll do the same thing, sine x plus 5 cos x. And it wants me to write it as r cos x minus alpha. Now r cos x minus alpha, and I expand that, I get r cos minus, oh, the sign does change in this one, plus r sine. Now where's the problem on this one? Just look, you've got sine x, this is the problem, the x's are actually over here. So I've just got to be a bit careful on this one. I've got to write 1 sine x is equal to that r sine alpha. So just line them up properly almost. And then 5 cos x, so that's the r cos alpha. So it'd be quite easy to get that one. I think from then on you should be okay. This is the one I'm more interested in, I suppose. So let's just go back to this one. What would I do in this example? Well, the fact that it's got a minus, I suppose I'm going to have to write here sine alpha. Well, I need my r first of all. R is still 2 squared plus 3 squared, which is root 13. So r is, sine alpha now is minus 3 over root 13. I'm going to move it over because the minus has moved and the r's then moved. And on this one, I suppose cos alpha is 2 over r, which is 2 over root 13. And now, just because I've got the minus, it may work, it may not. Let's just check it. So I've got to do, I'm in degrees, so let's make sure I'm in that degrees. Got there in the end. 2 divided by root 13 inverse cos, and I get 56 degrees-ish. And the other one, if I do the inverse sine of minus 3 divided by root 13, done it wrong. I get minus 56. So this is the kind of question I mean when I say that there's potential for going wrong. Now this method I will explain in class. Don't worry about it too much. Try and do the others. So the others basically